Welcome back to C# for Total Noobs on Developer Ramp-Up. In this lesson we'll go a step further on the journey to become a software developer and we'll start to talk about classes. Classes are really a fundamental concept of object-oriented programming, and C# is an object-oriented programming language, therefore classes are really important also in C#. That's why I would dare to say that beginning with this point where we'll start to work with classes, we can define ourselves as software developers. Of course, we still have a lot to learn, but this is really the point where we can say that we begin to be software developers. So let's get started, and first of all, let's think a bit about how classes work in object-oriented programming. A very cool thing about C# and other object-oriented programming languages is that they really try to model everything around real-world objects that define some certain properties. And real-world objects, as we know, they have often some attributes and of course some behavior. Let's take the example of a car. So a car is of course a real-world object. And when we see a car, we know that that specific object is a car because we have in our brains a mental representation on how a car should look like. And this would include maybe properties like the color of the car, like how many doors it should have, but it could include also behavior like the ability for a car to accelerate or to brake or to turn left or of course to turn right. So that's why when we see a car as an object and we see these type of properties, we can relate it to the mental representation of an object that a car should look like. And this is how we can define, okay, this is a car, this is a tree, this is a bank, and so on. In C# and other object-oriented programming languages, we do exactly the same thing. So what we try to do is to take objects from the real world, like a car, and to define it in C# or in the programming language that we want to learn. And this is why when we define how a car should look like in C#, so doing basically that or representing that mental representation that we have on how a car should look like, we can do this in C# by using a class. And classes describe the structure of an object or the structure of objects of that specific class type. So what we could do is, for instance, declare a class that would say, let's declare a class type car, and we could define in that class that, well, a car should have a certain number of doors. This is a property. We can define that a car should have a certain color, and this is another property. But we can also define, for instance, that a car should be able to brake, or that a car should be able to turn left or right, and so on. So this is exactly the same thing that we also need to do in C#. Now, the good thing is, or one thing to notice, that a specific object, like a certain car, is a particular representation of that specific class. So it's exactly the same thing as when we see on the street a car, we can relate it to the mental representation of a car that we have in our brain, and we can see, hey, that is a car. And this exact thing happens also in C#. We define a class car, specifying a lot of properties and methods, so actions that a car could perform. And afterwards, when we declare a new instance or we create an object of type car, we know exactly that it is a car because it has those properties that we have defined, and it also has the actions or the methods that we have defined in that specific class. So we hold information about these properties or about the attributes of a car in something that we call properties in C#. And these properties try to model really how a car should look like the number of doors that it has to have 4 wheels, and so on. And let's go maybe one step further and try to explain classes based on an analogy. So we all wait for Christmas when we can cook a lot of cookies, and we use for this type of thing cookie cutters. And classes in C# are in some way cookie cutters. Why? Because a cookie cutter is, let's say, a definition on how a cookie should look like. So a cookie cutter has a certain shape. it has a certain form, it has a certain size. So this is how we can define that all cookies that we do or that we create based on this cookie cutter will have the exact same form and size. And this is, for instance, how we can do the following thing. When we take a cookie and we look at it, we can see, hey, it was done with that specific cookie cutter. And cookies are basically the objects that result from using this cookie cutter. Of course, for us, we can consume the cookies, we can eat them, so we can interact directly with the cookies, so with the objects that result from using that cookie cutter or that specific class. So this is why cookies, or the objects that result from a certain class, are also called instances of that specific class. We can go even one step further and try to understand a little bit better how classes work. And here we have, for instance, two examples from which we have to understand that the class is something, but the objects is a total different thing, so they are not equal. And let's imagine that we have maybe a dog class that we define in C#. And in a dog class, we would probably define properties like the name of the dog, the age, the breed to which it belongs, and so on. And probably also an action of barking, so a dog should be able to bark. But then after we have done this, we can basically create new objects of that specific class. So we would end up having, in this case, three different dogs. One is called Spot, the other one is called Lucky, and the other one is Rex. As we can see, based on the fact that we have defined in this class dog what properties a dog should have and what actions it should be able to perform, when we see an object of that specific class, we are able to see, hey, this is a dog, because it has four legs, it is able to bark, and so on. But on the other hand, each object of that specific class is different. And we can see this also in this picture, because Spot has some characteristics, and Lucky has others, and Rex has others. And the same things we can do also thinking about cars. What we see here is the representation of a car. So the plan, the blueprint of a car, how a car should look like. It should have four wheels, it should have some doors, it should have a driving wheel, and of course it should be able to perform some actions like accelerate, brake, turn left, turn right, and so on. But then again, we have the specific objects of that specific class. So we have an object 1, which is a yellow car. We know that it is a car because we can see that it has all the properties that we have defined in that car class. But then the object 2 is an orange car, and once again we can identify that object as a car because it has all properties that we know that are present on that car class, which is a blueprint for every car. But the second car is different than the first car because in this case it is orange. And last but not least, we have also a third object of that specific class that is once again different in comparison to all other objects because it is a blue car, but we can say that it is a car because it has all the properties and characteristics that we know should be available on that car class, so on that blueprint that we have. So we can say that the class acts like the mental representation of objects that we always have in our mind, while the objects themselves are instances of that specific mental representation. Now, a final thing that I would like to dwell on before we go into Visual Studio is a certain type of definition or a certain information that we really need to learn. There aren't really a lot of concepts that I will say in this course are something that we need to learn. But in this case, this is one of them. So classes in C# could have the following members. Classes can have fields, can have methods, can have properties, and can have constructors. Now I have to say that this is kind of an oversimplification because there are also other class members that we could have in C#, but these four ones are really the core class members that we can have and with which programmers work really on a day-by-day basis. So this is why we will concentrate right now on these four class members. So once again, fields, methods, properties, and constructors. Now we will go to Visual Studio and we'll start playing with classes, and we will see exactly how we can implement properties, how we can define fields, how can we work with methods, and of course also we will look into why are constructors useful. So let's switch over. This is our My First App solution that we worked on from the beginning of this course, and I already have opened it so far. So if you don't have it open, you can now pause this video and open this solution so that we can work further. Alternatively, if you want, you can create a separate solution and project for working with classes. Let's get started. First of all, let's get rid of everything that we used during our last exercise on for loops, because we really won't need this anymore. And now we could start and define a class to see exactly how this is done. In order to do this, we have to recall a little bit what we did earlier, or what we talked about already in the beginning of these courses. So we see that in this document we have a certain structure. We have first a namespace that is defined by these two curly braces, or by this set of curly braces. And inside the namespace we have a class called program. And until now everything we did was in this class program. However, right now we want to create a new class. So therefore we have to make sure that we create the new class in the namespace, not in the already existing class. That's why we'll put the cursor here and press enter 1 or 2 times so that we make enough space for us to continue working, and we can define our own class. And since we talked a lot about cars, let's create a new class called car. And we do this by public class and the name that we want for our class, and this is car. And then we need these curly braces. And that's it, we already created our first class. Here we have to discuss a little bit certain components of this class declaration, let's say. We have first this public access modifier. So this is called an access modifier. We will talk about access modifiers in more detail a little bit later in this course. For now we can just stick to the idea that if we declare a class as public, we will be able to use this class almost anywhere in our program. Classes that don't have an access modifier specified, like this class program, these classes are private by default. So we will stick with public for now, because we want to learn right now exactly what are the class members and how can we define properties, fields, constructors and methods that can perform certain actions. And let's start by properties. So we have a new car class, and when we create a new object of this type car, we want that object to have certain properties or attributes if we relate to a real world car. And we declare properties in C# using following syntax. First of all, we will also use an access modifier, and for the sake of this demo, at this stage of this course, we will mostly work with public access modifiers. So after the access modifier, what we need to do is let's say declare the type, the data type of this property, and let's name is this string. So we want this property to be of type string, and then we have to give a name, and let's name this color. So this means that in this property we will define a color for each car object that we will work with. And then there is a special thing here for properties. We need these curly braces, and inside these curly braces we have to define this get and set. Now technically these type of keywords are also called getters and setters. The idea behind is that using a setter we are able to set the property to a certain value, and by using the getter we are able to retrieve the value of this property in our code. And I think we'll understand this a little bit better when we will instantiate a new object of this class car. For now, it's important to note that this is basically the syntax for declaring properties. So each time when you see a class member that has this get, set or getter and setter, this means that this is a property. And we should not, let's say, misinterpret this syntax for anything else like fields. These are properties. Okay, let's go one step further, and I want to show you a little trick here. Let's try to declare right now a new property. We want this car class to have a new property. For instance, we could use year for the year when the car was made. And if you type here prop and double tap tab, then Visual Studio will auto implement the property for you, of course with some values that are placeholders. And here we have data type integer, which is okay. We want to store our year as an integer, and we can say here year. Good, so this is another property of this class car. Let's also define a new property, and this property should inform us about the number of doors that a certain car has. So we'll go once again for prop, and we have this property int, and what we want this to define is number of doors. And we have a new property here and a typo, so let's correct this so that we have everything correct. And this is a third property that we have defined on this car class. Now, of course, we could go on and define a lot of other properties, but I think for now this should do it. Let's now jump over and try to understand how we instantiate a new object of this car class. And we'll go here back in the static void main method in the class program, because this method gets executed when we debug or when we run our program. And the way we do this is simply by specifying the type, which in this case is the class, which is car, then a name, car1, equals new car. And let's spend a few words on the syntax that we used here. Also, we can notice that it is kind of similar to what we usually see when we, for instance, declare a new variable like string something equals hello. So this is how we declare variables. And we can see that we have here a certain similarity, because what we provided here is first the type, and the type is car, so the name of the class. Then we provided the name, and then we provided this new keyword. And this basically means that what we're going to do is that we will construct a new instance of this type car. So using this new keyword, we will make sure that we have a new object that will have all these properties that we have defined here. And in fact, if we then use car dot, we see that we have here all the properties that we defined. And we can set a color. Let's say that the color is yellow. And we can also set the year. When was this car made? And this should be of type integer, so we don't need quotes, and we can say it was made in 2014. And then we have also car1, and we can define number of doors, and this car should have, for instance, 4 doors. So that's it. Now we saw exactly how we can create a new object of this class, which is a car. So the class itself is the blueprint, the information or the mental representation for how a car should look like. But when we create a new object using this new keyword, what we will get in this variable car1 is basically a new car as an object, and we can define on each car the color, the year, and the number of doors. We can see here that it's basically almost like this type of car is a new way that we can use our own custom data types as variables, and this is not totally wrong. So you could definitely say that. Of course, what we can do afterwards, we can, however, also delete this. For instance, we can use a console write line, and in this console write line, we could simply print, and this is why I will use string interpolation, and we could print car1.color. And in this case, when we run this program, I would expect that we would see here in the console the color of this exact object, which is car 1. And we can see indeed that right now yellow was displayed in the console because this is the color of the new car that we have defined. We can also go ahead and declare a new variable of type car, which would be car2, and this would be right now a total different object of this class. So now we have car1 with certain properties and we have car2 with certain properties. So we can define once again a color for our car, and in this case let's assume that our car is red. We can also define a new year for this car, when this exact car was made, and here we need a string, and this could be 2016. Last but not least, we could also define the number of doors that our car has. In this case we would go with 2 doors. So that's it. Right now what we could do in this case is console.writeLine, and here we can specify or we can display the color of the second car. In this case this would be car2.color. Right now we can run this program once again, and I would expect to see yellow and red in the console. That is the case, so the program executes as expected. What we've learned by doing this is that we can have one class that we have defined here as the car class, but then we can have different objects of the type car, and each object is different and therefore holds different values for the properties that we have defined here. So this is really similar to the way how we identify cars in real life. In our program, when we see this car 1, we know already that well, this is a car because it represents or it includes all the properties that we have defined on this class car. And in real life, when we see a car, we can identify that it is a car because it is compliant to a representation of a car that we have in our mind with all the specific attributes like color, year, or the number of doors. Of course, we could go ahead and list here a lot of other properties that should be specific for our car class, but for learning purposes, I think that it is enough for now. And this is also how we learned to use these properties. So each time we ran, for instance, car1.color equals yellow, what we basically did is we used the setter in color to set the color to yellow. Then when we displayed the color, we basically used the getter from this color property to get the property that we previously set. So this is basically how the getters and the setters work. Of course, in the getters and the setter, we can also define our own logic, like for instance, we could do some validation. But for the purpose of this training course, I think it's enough to see that we have properties that are defined by using these getters and the setters. And we use them every time we set a value for a certain property like we did here, or every time that we want to display a certain property or to read a certain property to get it like we do in this case. I think that's enough for properties right now, and we can now change to another topic or to another class member that is very important, and this is the constructor. We can start a discussion about constructors by asking ourselves if there is an easier way to instantiate an object with all those properties that we have defined here. What I mean by this is that we have created a new car, but afterwards we had to specify a value for each of the properties, so for color, for year, and for numbers of doors. And then when we created a new object of this class, so we had car2, we had once again to assign a value to all properties, like color is red, year is 2016, number of doors equals 2. We want a way to simplify this type of object creations, so the moment when we want to instantiate a new object of this type car. This could be achieved, of course, by constructors. Let's put the mouse here and press enter a few times so we can make a little bit of space for our constructor. And here I can already show you a trick. If you type here ctor and double press Tab, Visual Studio will auto-implement a constructor for this class. What we can notice here is that we can use this public keyword, so the access modifier. We already said that for the sake of this course right now we will always use this public keyword. And then we have the name of the class. So a class constructor always needs to have the same name as the class itself. Then we have a set of parentheses right here. And then we have, of course, this code block. In this code block we could write, of course, some logic or some things that we want to customize in our car class right when we instantiate a new object of this type car. Right now, if we go ahead and build this program, we see that we don't have any errors here. So by adding this constructor, we basically didn't change any behavior of our class. Let's run this program. I would expect to see here the exact same result that we had previously, and indeed this is the case. So you might ask yourself, okay, but why do we need a constructor? Well, the answer is fairly simple. Because in this parenthesis here, this constructor can take some parameters. So what do I mean by that? Here we could define that when we want to instantiate, or when somebody in our program wants to instantiate a new object of this type car, they need to provide a string which would represent the color. They would have to provide an integer that would represent the year. And they would have to provide another integer that would represent the number of doors. What this means here is that, of course, when we instantiate a new object of this type, we will also have to provide this type of information. And since this information is missing right now, we already see here in our code a new red squiggly line under car. And if we read the message here, it says that there is no argument given that corresponds to the required format parameter color of car. So what this means is that basically we defined in our constructor that, hey, you need to provide a color, you need to provide a year, and you have to provide a number of doors. But when we constructed the new object, we didn't specify this type of information. So let's go ahead and specify. So we need here a string that would be yellow for car 1. We have to specify a year that would be 2014. And we have to specify the number of doors, which is 4. And in this case, you see that the red squiggly line has disappeared. So this means right now that our code runs correctly. Now we can simply delete this type of property declaration and initialization. And of course we can do the same thing for car 2. Here we could provide red as the color. We could provide the year 2016 as the year when the car was made. And the number of doors too. And once again, the red squiggly line has disappeared. So this means here that, okay, what we can do is simply we can delete this information. So all the code where we basically set a property or set a value for the properties that we have on this car class. And if we run the program right now, it would be strange, because what it would happen, nothing will be printed in the console at all. So we didn't achieve anything. But what we can do in the constructor is, okay, we know that when we instantiate a new object of this class car, we need to provide this type of information. And what we can do afterwards, of course, is set the properties with the values that we get from the constructor. So we could set color equals color. We could also then set year equals year. Sorry for the typo. Last but not least, of course, we can say that number of doors would be equal to number of doors, which is the value that we have received in the constructor. And right now the behavior should be a little bit different, and what I would expect is to see a result similar to what we had previously and see yellow and red. This is the case. So right now our program performs correctly. What we have done here is that we have used a constructor where we have defined that when you instantiate a new object of this car class, you need to provide a color, you need to provide a year, and you can provide also number of doors. Then we set the information or the properties of the car, so the color, year, and number of doors, to the values that we got into the constructor. And here we provided the values. Right now there is another thing that we can do. What if we want our class to support different types of scenarios? So what we want to achieve is, for instance, offering the opportunity to provide values in the constructors and setting the properties, but maybe we want to give the consumer, so the part of the program where we create a new object, also the freedom to instantiate or to create a new object of type car without specifying this type of information in the constructor. What we can do in that case is we can simply add another constructor. So it would be public car, and then we have these parentheses and curly braces. What we have done here, we have defined a new constructor. Right now it is possible to create a new object. Let's name it car3, of course of type car, and here we can also create new car, this time without specifying any values. And you notice here that in this case we do not have a red squiggly line. This is because in our class we have defined two constructors. So one constructor in which we have to specify a color, a year, and a number of doors, but we have also provided a new blank parameterless constructor here. This means that when we want to instantiate a new object of this class, we can either use this constructor like we have done here with car3, or we can use this constructor here like we have done here in case of car1 and car2. The idea behind this is that you can have in a class several different constructors, and each constructor can take a different set of arguments or incoming parameters that you can use, of course, afterwards in a class to perform some basic logic. So you can simply set this color, so you can set the property of the class to some values that you take from the constructor, but you can also provide a simple constructor, a blank constructor, that really doesn't take any type of argument and doesn't do any type of logic. It just simply enables us to instantiate, so to create a new object of this car class without specifying at the creation point any information. You might ask yourself then, okay, but right at the beginning, after we define the properties, we already were able to create new objects of this car class, but we didn't have any constructors. Well, that's true, but the reason why this happens is that if you don't provide any constructor at all in your class, .NET will provide a simple default parameterless constructor by default. So even if you don't specify it, but if you don't have any constructor at all defined in your class, .NET will know to instantiate a new object of this type car class by using this default blank constructor. The idea is that you could also add a third constructor and a fourth constructor and so on. It's really based on the logic that you want to implement and the freedom that you want to give, or the different options or features of this class that you want to give to the part of the program that consume your class. So this means basically where we declare and where we instantiate new objects of this car class. That's almost it for constructors. So let's go right now to another very important topic when we think about classes, and this topic is fields. So fields are also a class member. We can go here with our mouse and make some space because I want to define a field right here at the top. And let's start by defining a field. In this case, I would set this access modifier for this field to private, and I will have to provide a data type, so I want this to be of type string and then a name. Let's name this field manufacturer. The idea is that we don't have any property that is called manufacturer, but instead we want to use a field for it. Looking at the syntax of this field declaration, it's very important to notice that we have also to provide an access modifier, a data type and a name, but we don't have a getter and a setter. So each time you see in a class something similar to this, this means that that specific member is a field. And if it has getter and setter, it is a property. And this distinction is really very, very important to make. You don't have to misinterpret or let's say confuse or get confused by these two types of different class members. So properties always have a getter and a setter, but fields instead do not have getters and setters. And there is one thing that I want to mention here when it comes to the syntax of this field declaration. You might notice that I have used here this underscore. So this type of naming fields is really not very important, and we cannot say that it is a global rule. This is a preference that I would have, and also other developers, I'm really not the only one, to always prefix the fields with this underscore. And this is another way to visually say or know for myself that, hey, always when I use this underscore, this is a field. And we'll use this field just in a little bit of time to see exactly what we can do with it. Before going further, let's notice that we do not have here any manufacturer. So what can we do here to use this field? This could also make a transition to another class member that we really need to discuss, and these are methods. So let's go on to methods. Here I would like to define and to start working with methods after the properties the declaration. Let's for instance assume that what I want to do is when I have a new object of this class car, I want to have also an action. Actions are always called methods in .NET or in C#. What this means that anytime we want to perform a certain calculation, a certain algorithm, then we have to use a method. So in the properties we can set some values. In the fields we can also set some values, as we will see just in a few minutes. But in methods we can describe actions, we can describe algorithms that can be ran when we want to call that specific method. And let's try here to implement a very simple method. This method would also be a public method. We would also have to provide a return type, because in this case we want our method to return something, and we will see just in a while what this exactly means. Then we would have to provide the name of this method. In this case the name would be get manufacturer, and we have to provide this parentheses, and afterwards a set of curly braces which define a code block. So this is really our first method that we have written here by ourselves. When we think about it, we already worked with methods, because everything that we have in this class program and static void main method is nothing else than a method. So some actions that we provide or that we want to make when this method is called. What we do here is that, of course, this is the method that gets called right when our console application gets executed, and then of course it will create our objects and it will print things to the console, and it will eventually stop when it hits this console read line. The exact same logic we can implement, or based on the exact same logic we can implement some type of behavior here in this get manufacturer method. The idea of this method is that when it gets called, it should return the name of the manufacturer. So that's okay. What can we do right now? We can here in this method use this keyword return, and this means that we will return something. and we will return this field manufacturer. Right now this field doesn't have any value, but we'll come back to this just in a short while. Remember, when we declare the method, we set the access modifier and then we declare the return type. So this means that we always, when we return from this method, it should be a string. Here we see that manufacturer is declared as a string, so that's why, for instance, there is no error when we want to return a manufacturer. Let's just, for demo purpose, change the return type of this method to integer. So in this case, it would be expected that our method should always return an integer, so a number. But our field here is of type string. So this is why we get this red squiggly line, which says that it cannot convert implicitly a type int to type string, or type string to type int that we have to return here. So let's switch back and return a string because we don't want to have any errors. Let's go now back to the field. Here in the field, there are several ways in which we can set some values. For instance, we can declare the field, but then also set it to a certain value. And let's give the value here Ford. This means that the manufacturer of this class is Ford. Right now we have also this method, so let's go back to our console application, so where we define all the logic of our program, and let's try to add here a new information. We can print to the console, so console write line. What we can do here is simply use also string interpolation, or we don't need to use string interpolation. We can simply type in car3, and when we press dot, we see here that we have this method getManufacturer that we have previously defined. So if we call this method, and always when we call a method, we should use the name of the method and this set of parentheses. Right now I would expect that when I run the application, it should also display the manufacturer for this car3. Here in fact we see that we have yellow, red and Ford, which is the manufacturer that we have previously defined in this field. The idea is here that we have used a field in which we provided a certain value. The consumer of our class, so basically the place where we created a new object of this type class, doesn't have to know that we have internally in our class a private field that is called manufacturer. But the consumer will know that we have a method that is called getManufacturer, and it would always expect that it will return a string. So this is why we can simply put here in this console write line this car3 and getManufacturer, because when we execute this part of code, so when we execute this method, what we will get as return type is a string, and in console write line we can simply write a string. Alternatively, maybe to better visualize it, we could declare a new variable of type string, and it should be manufacturer. And here we can use car3 and getManufacturer. Here in this console write line then we could use the variable that we have previously defined. And by the time the code execution will hit this console write line, manufacturer will have the string value that was returned by this getManufacturer method. If we run the program right now, we should be able to see exactly the same thing, but what we have done, we have used here a variable instead. As we have seen, we could also call the method directly here in the console write line method. And since we're speaking of this console write line method, if we notice here what is this type console, if we press F12 on this, we go to the definition of this console, and we see in this definition that it is a class. So the console that we have used so far is a class, And the writeLine method, if we go to the definition once again, we see that it's a public static void method, which means that it is an action. So this is also just a simple method. Like we have defined our own method earlier when we have implemented this get manufacturer. There is right now, however, one last thing that I want to specify when we are talking about fields. In this case, for instance, well, we don't know exactly what manufacturer each car is. So what we can do instead is we can instruct the consumers, so the code blocks or the code parts where we will instantiate a new object of this type car, we can instruct it that, hey, you can also provide a name for the manufacturer for that specific car. And in that case, we have to use another constructor. Here we can define a new constructor as said, CTOR and double press tab. Here we can specify that what we need when we want to use this constructor is a string that represents the manufacturer, which would be okay. Now what we can do here is simply we can use this field, manufacturer, and set the value of this field to the value or to the information that we receive when this class gets, or when an object of this class gets instantiated. What this means is that we can go back here in our code, and for car3 we could change this. For instance, we provide a new string which would be BMW. Sorry for the typo. In this case, we have provided an information, and due to the fact that we have only one constructor that takes in only one string that represents the manufacturer, .NET will know that, hey, in this case we want to use this constructor. And when this constructor is used, the field would also be set, the value of this field manufacturer will be set to the value that we pass when we instantiate the object of this specific class. So right now, if we have this car3 get manufacturer, we don't have to change anything there. But right now, if we run the code, what it will happen is that it will display BMW. This is because we have used that specific constructor. In fact, we can also put a breakpoint here to see exactly what happens. So let's run this program once again. We will hit this breakpoint right when the execution gets to this constructor. So right now the execution is here. This means that we were previously at car3 where we instantiate a new object. Since we provide only one string, .NET can map this to the constructors that we have defined and will know that, hey, this is the constructor that I should use. Indeed, this is also the case. If we hover the mouse over it, we can see the value of BMW. Afterwards, we see that we have this field which is still null, so it doesn't have any value. But if we go further and execute the code block in this constructor, we'll see that afterwards manufacturer is set to be BMW. A little bit later, when this method gets called, and we can set also a breakpoint there, we can go further. So we will instantiate this new BMW, a new instance of this car class, so a new object. Then we'll write something to the console, and then we'll get to the point where this get manufacturer option will be called, or this get manufacturer method will be called. So when we execute it, we see that we hit this breakpoint. Right now we see that our method doesn't do really spectacular things. It simply returns the value of this manufacturer field. The value of this field is of course BMW because we have set it in the constructor earlier. Right now we can press on continue and we'll see the result that we have also seen previously. That's it for now. We can simply clear these breakpoints because we don't need them anymore. To make a short recap of what we did with this class. So we have seen how we can define properties. They are always defined by having these getters and setters. This means that when we instantiate a new object of this car class, we will be able to set the property using the setter, and to get it, to read it, to display to the console as we did using the getter. Then we have discussed also the idea of constructors. And we have seen that by default, if no constructor is provided at all in our class, .NET will use a default constructor that doesn't take any information and doesn't perform any type of logic in this code block. It would simply construct a new object of this car class, but without setting any properties to any values. We have added also other constructors like this one, where we take some information when we create the new object, and then we map that information to the properties that we have defined earlier. We have also worked with fields. We have defined here a field that is private, so the information here is only visible within this class. No one from externally, so when we create a new object of this class here, will be ever able to see what we have in this field. So this is why fields are usually used to store some state, to store some information, or connection to a database, or some HTTP configurations, and so on. The idea is that if you don't specify any constructor, as mentioned also earlier, this constructor, this default constructor, will be used. But if you specify at least one constructor, then you would have also to explicitly provide this default constructor if you want to still be able to create new objects of this car class without providing any type of information. Last but not least, we have created our own method, this getManufacturer, and here we have combined this also with the utility of our field. So we take this information that is set in this constructor and we simply return it when this getManufacturer method gets called. For the method itself, we need to have an access modifier. We need to provide a returning data type because in this case we know that we want to provide a certain or we want to return a certain value, in this case the string manufacturer. And then we have this set of empty parentheses right now that also represent a certain method. So when you always see these parentheses here, it means that this is a method. And if we go back to the constructor, we see that here we also have parentheses. This is because if we think very simply, a constructor is nothing else than a method that constructs an instance of this object or constructs a new object of this car class. So a constructor is in the end also a special type of method, I would say, but it's a really special one, so this is important to note. Coming back to the method, these parentheses, as said, mean always that we have a method, and they need to always be followed by curly braces that define a code block. And in this type of code block we can put our logic, our algorithms, or things that we want to compute. So our code gets executed when this method gets called. That's mostly it for now. In the next lesson we'll go a little bit further and we'll look into different type of methods, like for instance static methods or non-static methods like this one. We'll also look into methods that do not return anything, that are called void methods, and we'll try to play a little bit with classes and build really a very small but logical real program in the console. Thank you very much for watching, and I hope to see you in the next lesson.